Now let's look at it from the point of view of those operations. Right? The differentiation, what is it? Well, differentiation is an operation that takes a function, gives you a new function. Integration is also an operation. Takes a function, and at least this way it gives you a new function. If you keep one limit, change the other one. So, what are we doing here in this formula? I start with the function f. This is just a way to think about this formula. You start with the function f, you differentiate it first, and then you integrate it. And what are you getting back? Let me make it a formula. I take f, I differentiate it, then I integrate, and I would like to do the same. I would like to keep lower limit a constant, upper limit a variable. What do I get? I get f of t minus f of a. So I'm getting the same function back minus a number. Right now we think about this as a function of t. So as a function of t, this expression is indeed a function f minus some fixed number that doesn't depend on t. So in this context of single variable calculus, when we only consider definite integral as a function of one variable, the combination of operations, derivative then integral, gives you again the function back up to a constant. So the consequence is that, our third consequence for today, is that if you differentiate a function and then you integrate a function in that very precise way, the result is the same function back minus a constant. So in that sense, differentiation and integration are almost inverse operations. And as we go into multivariable calculus, that will be even less precise, and we will have to develop some means and tools to understand what multivariable or fundamental theorem of multivariable calculus is. But this is exactly what we would like to implement for the multivariate version of this theorem, saying that differentiation and integration are inverse operations in some sense. Alright, so basically these are all the basic tools we will need about the integral. A way to compute an integral and a way to differentiate an integral.